Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors as velocity. So as per the problem, an airplane heading north has an airspeed of 600 kilometers per hour. In part A, if the airplane encounters a wind from the north at 100 kilometers per hour, what is the resultant ground velocity of the plane? So let's start with part A. So we have an airplane that's heading north and has an airspeed of 600 kilometers per hour. So we can draw a vector for the velocity of the airplane in the upward direction. So let's assume this vector represents the velocity of the airplane. Now as per part A, the airplane encounters a wind from the north at 100 kilometers per hour. That means the wind is blowing from north to south. Now since the speed of the wind is 100 kilometers per hour, the length of this vector should be 1/6 the length of the airplane's velocity vector. So we don't have to do an exact measurement for it, but it should look like it's 1/6 of the airplane's velocity vector. So this vector can represent wind's velocity. Now we have to find the resultant ground velocity of the plane. So that means we have to find the resultant velocity of the plane, and to find the resultant velocity we have to arrange the vectors in tip to tail format. So this is the vector for the airplane's velocity, and now the wind's velocity vector can be shown like this. Now I did not put the wind's vector on the airplane's vector because then it will be difficult to differentiate between the two. And the resultant of these two vectors will be this vector. So this is 600 and this is the resultant vector. Now we can write the equation for the resultant of the airplane's ground velocity. So vector v1 represents the airplane's air speed and vector v2 is for the wind. Now the wind is blowing from the north, so that's why the direction of the wind's velocity is south. Now we cannot add these two vectors algebraically because they have different directions. So we have to change the wind's velocity direction from south to north, and that will make the vector negative. And now we can combine the two vectors. So we get and the direction is north. So this is the resultant ground velocity of the plane. So this should be the final answer for part A. Now we can analyze part B. If there is a wind from the south at 100 kilometers per hour, what is the resultant ground velocity of the plane? So in this case, the wind is blowing from the south. So the velocity vector for the wind will be the direction of the wind is north. So now we can draw the vectors for the velocity of the airplane and wind. So this vector represents the airplane's velocity, and the wind velocity is also in the north direction. So the resultant for these two vectors will be this vector. Now we can write the vector equation for the resultant. So V1 is for the airplane and V2 is for the wind. Since these vectors have the same direction, we can add them algebraically, and the direction will be north. So this is the resultant ground velocity of the airplane for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.